Hi, in this video, we would like to see how we use limit to solve the horizontal asymptotes. If you remember, in P calculus, we talk about the horizontal asymptotes that if we have a functions as x approach infinity or go to infinity, right? Then the function, the output y is getting closer and closer to a line, L. Then in this case, the function approach L. So in this case, we say that we have a horizontal asymptotes y equal to L. Okay. Then now, limit, how do we actually show that? Is that let f be a function defined on some interval from a to infinity. Then we have the limit x approach infinity of f of x equal to a number L, mean that the values of f of x can be made arbitrarily close to L by taking x sufficiently large. Okay. And you will see that the function f, sometimes it could, that's mean above the L, sometimes it's below L. Okay. Or just alternating between the function y equal to L, this line right here. Okay. So what if the function has x approach negative infinity? If y go to L, then in this case, we also say that we have a horizontal asymptotes y equal to L as well. Okay. And to the limit is the limit x approach negative infinity of f of x equal to L. Okay. Now, a lot of students is actually confused between this one and the lecture that we have last. To this one, the limit does not exist, but it tells us the behavior of the functions when x getting closer and closer to a from the left or from the right, the output of the functions go to infinity. Okay. Then this one right here is related to the vertical asymptotes at x equal to a, right? On the other hand, when we have the limit x approach positive or negative infinity of f of x, if it is equal to a number L, in this case, the limit exceeds, and in this case, we say that the function f has horizontal asymptotes at y equal to L then. Okay. These definitions is tell us that the line y equal to L is called horizontal asymptotes of the curve y equal to f of x if either the limit x approach infinity of f of x equal to L or limit approach negative infinity f of x equal to L. Okay. Then now let us look at the following example one now. So to this example, we would like to find out what is the limit has x approach infinity, negative infinity, okay, of g of x, or has x approach 2 from the left-hand side and the right-hand side, okay? And then let's see what is going on there. So when we have has x approach infinity or negative infinity, that means in this case, we are talking about the horizontal asymptotes, okay, of the function g. Okay. Then in this case, you will see that as x go to infinity, as x getting bigger and bigger, then the functions g is getting closer and closer to this line y equal to 2. So in this case, we could say that the limit x approach infinity of g of x equal to 2 then. Okay. So now try to pause the video and then to see if you could finish the rest of the problem. Now, the limit x approach negative infinity of g of x. Okay. You will see that as x approach negative infinity, then the functions, right, is getting closer and closer to this horizontal line, y equal to -1. Okay, so therefore, in this case, my answer will be -1 then. Okay. Then let's check it out. As x oppose 0, so if we just have x oppose 0, do not have a sign positive or negative, meaning in this case, we are looking at from the left and also from the right then. And x equal to 0 is, this is the line, x equal to 0. You will see that from the left and from the right, the output is getting bigger and bigger in the negative side, right? So that means my answer would be negative infinity now. Okay. And to the problem D and E, we look at as x approach 2 from the left and from the right. So then let us label where is x equal to 2 on the graph. Okay. Then from the left, as x approach 2 from the left, the output is getting bigger and bigger negative. So therefore, in this case, my answer will be negative infinity. And of course, as x approach 2 from the right, then the function is getting bigger and bigger, the output, right? Bigger and bigger and bigger to infinity. So in this case, we have two types of asymptotes to this function g. We have horizontal asymptotes, y equal to 2 and y equal to -1. We have a vertical asymptotes, x equal to 0 and x equal to 2. And now, let us look at the following example. How do we actually sketch the graph of the functions that satisfy the different conditions? So in this case, when we try to graph, okay, functions, what we would like to do is we want to get the informations, right? Then now, let's see. So the first two limits, actually the first three limits is talk about the vertical asymptotes, and these two is actually talk about the horizontal asymptotes, and this one is talk about point, right? Okay, so let's see. So the first one, we have the limit x approach 2 of f of x equal to infinity. So meaning I will have vertical asymptotes at x equal to 2. And the next two is we have x approach to -2 from the right and from the left. Let's go to negative, from the right, go to infinity, from the left, go to negative infinity. Again, we have another vertical asymptotes at x equal to -2. And now, as x approach negative infinity or positive infinity, the output of the functions is equal to 0. Then in this case, we have a horizontal asymptotes, y equal to 0. Okay. And the last situations, we have a point 0, 0. Okay. So then now, let's see if we could sketch the function now. Okay. And first, I would like to put down the scale. On the x-axis. Okay. And then now, let us sketch the first. We have a vertical asymptotes as at x equal to 2. We have another vertical asymptotes at x equal to -2. We have horizontal asymptotes y equal to 0. And we have a point at 0, 0. Okay. Then now, to the vertical asymptote x equal to 2, then the output, right, from the left and the right is go to infinity. Okay. And then now, this one, as x approach to -2 from the right, go to infinity. From the left, go to negative infinity. Okay. Okay. So now we could actually sketch the function now. So consider this arrow and this point right here. Okay. So we would like to connect this arrow to this arrow, go for this point. So we could actually do it this way. Okay. And then now let us look at this one now. Okay. We know that the functions basically is, again, to this one, okay, we have a horizontal asymptotes. Basically, the function is decreasing from, again, negative infinity. And then when it's getting closer and closer to -2, then it's go to negative infinity. Mm-hmm. On the other hand, to this side right here, then we have this. Again, we have a horizontal asymptotes y equal to 0. That means the function basically stay above y equal to 0 and then go to infinity then. Okay. And now maybe it's your turn. Now go ahead and try to see if you could work on the B. Okay. Now to B, this is actually is an information that you need to know. Okay. So if you have a even functions, okay. So what does this mean by even function or odd function, right? So if f is even, in this case, if you have one side of the functions, for example, if the function is look like something like this, okay, maybe I make it like this. Okay. Then if the function is even, meaning it is symmetric with respect to the y-axis, and then meaning you have the image going this way. Okay. If f is even. Then what if f is odd? If f is odd, the idea basically is you have a refractions, okay? Kind of like this. We have a refractions, or maybe it is symmetric with respect to the origin, okay? So basically it means that it looks like that you have again, the function basically is you have a reflection about the x-axis first, and then you are going to have the reflection about the y-axis. Okay, so then this is kind of like the final graph that you have. It is look like something like this. So if the function is odd, then it's symmetric with respect to the origins. If the function is even, then it is symmetric with respect to the y-axis. Then, okay. And now let us look at this problem now. Okay. So now let us try to see how we gathering the informations. Okay. So to this one, I this limit tell me that I have a vertical asymptotes is x equal to 3. To this one, essentially is tell me that I have a horizontal asymptotes, y equal to 2. Okay. And this one is tell me that I have a point 0, 0. Okay. Okay. So again, I would like to put on the scale. And I have a vertical asymptotes at x equal to 3. I have horizontal asymptotes y equal to 2. Okay. And I have a point 0, 0. Then check it out. The limit x opposed 3 of f of x equal to negative infinity. So from the left and from the right, okay, the function is actually pointing down, right? And now let's see how we finish the graph. First of all, we will have the graph basically to this side right here. Maybe it will go for some number, right? And then to this one, it will connect it to 0, okay, to this arrow here. Okay. And now I'm going to finish the graph now. So Based on what we know about even functions, we have symmetric with respect to the y-axis. Okay, so then in this case, we are going to work with the image. Then this is y equal to 2. And we will have another at -3. We have another vertical asymptotes, x equal to -3. Okay. And then we will, from here, go to negative infinity. And then to this side, we will start from negative infinity, right? It's getting closer and closer to this line 2, y equal to 2. And then it will go down. As is opposed to -3 from the left, then the output is getting closer and closer to infinity. Okay. Yeah. So then this is actually a possible function for f of x now. Then now, let's try to graph the function first. And then after we've graphed the function, then we need to find the formula. Okay. Then satisfy the following conditions. Okay. So let's see how do we actually do this. The first limit tell me that I have horizontal asymptotes y equal to 0. The second limit tell me that I will have a vertical asymptotes at x equal to 0. Okay. F of 2 equal to 0 tell me that I have a point to 0. This one, x opposed 3 from the left and from the right go to negative infinity or infinity, meaning we have another vertical asymptotes at x equal to 3 then. Okay. Okay. Okay, so then so let's put down the scale. On the x-axis. Okay. We have a vertical asymptotes x equal to 0 and x equal to 3. We have horizontal asymptotes y equal to 0. We have a point to 0. Okay. And now x opposed 0 of f of x is equal to negative infinity. F of 2 equal to 0. And then we have from the left, has x opposed 3 from the left, go to infinity. From the right, negative infinity. Okay. So if we graph from left to right, then we will have the function is decreasing. And as x is getting closer and closer to 0, the function is go down to negative infinity. And the middle, right? So x starting from negative infinity and then connect to 2 and then go to infinity. The last portion, the functions is increasing, but it will stay below the y go to 0 this line. Okay. Then let's see how we actually find the formula now. Okay. Then we have to go back to p-calculus now, right? Okay. So in p-cal, then we have learned that when we work with the rational function, basically it will be p of x over q of x, where p and q, they are polynomial functions. And also one thing about this is the p function is related to the x-intercept. Okay, we could have, if we have the x-intercept, x of 1, x of 2, is x equal to x of 1, x of 2, x of 3, and so on and so forth, up to x of n. Then to the p function, then we will have x minus 1, x minus x of 1, x minus x of 2, x minus x of 3, and go down to x minus x of n. Okay. And then to each factor, we also have a power. And then how do we determine the power? If P, the power, is equal to 1, 3, 5, okay. Or maybe let me talk about 1 first. Then basically the function will cross the x-axis, okay. Just calculate a straight cross, okay. And then if it is 3, if the power is odd, 3, 5, okay. Then when it's crossed the x-intercept that we have, it's just like a chair, okay. And if P is even 2, 4, 6, 8, then basically the function will again consider this x-axis. Basically the function is just touch. Is touch it this way or is touch it this way? Just touch the function, okay, as the x-intercept. Okay. Then now, how about the denominator? Then the denominator is related to the vertical asymptotes. X equal to v sub 1, v sub 2, okay, up to v sub n. Then same thing, I will have x minus v sub 1, x minus v sub 2, minus v sub 3, and then up to x minus v sub n. Or maybe we call m then. And again, we also have the power. Maybe we call the power q then. Q sub 1, q sub 2, okay, up to q sub n, okay. And again, how q affect the functions. So if, okay, if q is odd, meaning 1, 3, 5, then basically when the function nearby with the vertical asymptotes, then in this case, the function basically is behave this way, okay? If from the left, they point to negative infinity, from the right is point to infinity, or the other way around, if from the left is point to infinity, the right is actually point to different directions. The behavior is just like 1 over x, okay? And if Q is even, meaning it's about 2, 4, 6, 8, like this, then in this case, then the behavior nearby the vertical asymptotes is both, okay? The function approach the vertical asymptotes is either go to infinity or go down to negative infinity. Okay. When you see the situation like this, then the power of each factor, we call multiplicity, okay, must be even. If they point to different directions, it must be odd. Okay. And now let us go back to our problem in this case right here. Okay. So if I want to find f, then first of all, we find out that we have the x-intercept at x equal to 2. Okay. Then in this case, what is the power? Okay, we call it the multiplicity. What is the power of this factor here? It will be 1, because this one is just like a strict cos. Okay, just like this. And now we have two vertical asymptotes. X equal to 0 and x equal to 3. Okay. Then the power of the vertical asymptotes at x equal to 0 is 2, because they point to the same direction, right? And then for x equal to 3, it will be 1 then, because they point to different directions, the opposite directions. Okay. So then now we could write out that is f of x is equal to, if x is equal to 2, then meaning to this factor, it will be x minus 2. Okay. Again, it's just like you have x minus 2 equal to 0, right? So now I will have x minus 2 all over. This one will be x squared. And then this one will be x minus 3 then. Okay. Relate to vertical asymptotes. Relate to x-intercept. Okay. Or what we call the zeros. Okay. Or root. Right. Okay. Then now there's one more thing that we need to figure is actually we need to figure out that what A is, meaning this one is what we call the stret factors, okay? How the function stretted, okay? And then to this A right here is also related to either A positive or A is negative then. Then now, because we don't have any scale on the Y, so therefore in this case, the best solution to this A right here is either positive or negative, nothing else, okay? So in this case, maybe let us assume if I assume that A is positive. Okay. If A is positive, then f of x is x minus 2 over x squared, x minus 3. Okay. Then let us test this. If I take the limit x approach 0 from the left, of x minus 2 over x squared, x minus 3. Okay. Then the number that we could plug it in, maybe we could using negative 0.1, right? Okay. Then now, if we replace x with negative 0.1, then let's check it out, the sign. Then the top is negative. Then negative 0.1 to the square is positive. And negative 0.1 minus 3 is negative. Okay. So it's turned out that this one is a positive infinity. Okay. So to this one, has x approached 0 from the left-hand side, the output is infinity, which is contradict with the graph that we have. So therefore, in this case, A must be negative then. Okay. So we could make the conclusion that f of x equals to negative x minus 2 divided by x squared, x minus 3. So if you want to see more example about how we find functions of a rational functions, okay, you could actually let me know, okay, send me an email. Then now let us talk about the next theorems. Okay, it said that right here, if r is greater than 0, is a rational numbers, then the limit x approach infinity of 1 over x to the power of r is equal to 0. So what does this mean here? Then let us look at the following numbers, right? Okay. Now, think about this. If I have 1 over 10, then the answer that you have is 0.1. 1 over 100, 0.01. 1 over 1,000, 0.001. Okay. Do you see that if the denominator that we have is getting bigger and bigger to infinity, what happened to my output? My output is getting closer and closer to 0. So in some sense, if I have something that, okay, like 1 over x, so has x go to infinity, then what happened to y? Y basically go to 0. Okay. So this is the idea about this theorem. Do you see that if I have 1 over the number that is getting bigger and bigger to infinity, then my output is equal to 0. Okay. Same thing with the other one right here. If x getting bigger and bigger to a negative right here, then what happened? My output again is getting closer and closer to 0. Okay. Again, let us think of this situation. 1 over negative 10 is negative 0.1. 1 over negative 100, negative 0.01. 1 over negative 1,000, negative 0.001. Do you see that the output that we have is getting closer and closer to 0? Okay. Okay. Then now, why this theorem is important? Because when we try to find the limit has x go to infinity, from time to time, these theorems right here is work, right? Work best to the situation then. Okay, so let's see how we actually use these theorems right here. In order to use the properties of the theorems for finding the limit of rational function has x approach positive or negative infinity, we first divide each term of the numerator and the denominator by the highest power of x percent in the denominator. This is really important. And then we determine the limit of the resulting expressions. Okay, so then now let us look at our first example. Okay. Now, when we look at the example to this function right here, x to the power 4 plus x to the power 5, okay? Then to this one right here, before calculus, probably you know that the answer is when we have the polynomial function, what we want to do is we would like to look at the term that contains the highest power. And then you will see that the behavior of the functions will look like x to the power 5. And the answer to this one right here, okay. So in this case, the answer that we have has x approach negative infinity. The output that I have is actually is negative infinity, okay. This is actually is when you were a PCAL student then, okay. But right now, we have to see if we could use like algebra or the limit to help us to take care of the problem then. Okay. So let's see how we actually work it out this problem. Okay. So one way to work on the problem here is we could consider that again, I still take the limit x approach negative infinity. Okay. Then now what we want to do is we would like to factor out the highest power x to the power 5. Okay. So if we do this, then what happened to this? Oh, maybe let us go back to the idea about factoring. Okay. So when I have x to the power 4 plus x squared, then usually when we try to factor, we would like to factor out the term contain the less power, right? Like this one, we would like to take out the x squared. Then what happened to each term? Basically, we subtract each power by 2. Okay. And of course, then we will have x squared plus x to the power of 0 and x to the power of 0 is 1. So then now we actually, this is the idea about factoring, right? Okay. So right now, if we try to factor out the power 5, then what happened to each term? Then in this case, we would like to subtract 5 from the power. Okay. And now I will have the limit x approach negative infinity, x to the power 5. And this one will be x to the negative 1 plus x to the power of 0. And then now we take the limit x approach infinity of x to the power 5. Then this is 1 over x plus 1. Okay. Then now, as the limit x approach infinity, this term go to 0. We are using this property right here. Okay. Because in this case, R is 1, right? So we know that the answer is 0. Then we will have the limit x approach infinity of x to the power 5. Okay. So then now we could actually work with these functions. So then as x go to, oh, it should be negative infinity, my bad here. Okay. So as x getting being equal to the negative side, okay, then my output is go to negative infinity. Then. Then now let us look at our next example. Okay. So to this example, okay, then what we can do here is we could actually work with the situation like this one right here. Okay. What we would like to do is, again, we would like to work with the highest degree in the denominator then. Okay. Then when we see that to this problem, the denominator carry x to the power 3. So what I'm going to do here is I would like to multiply top and bottom of the expression is 1 by 1 over x to the power 3. Okay. So if I do this, and now you will see that we have this term times this. Okay. Then I have 4x to the power 3 divided by x to the power 3 plus 6x squared divided by x to the power 3 minus 2 over x to the power 3 all over 2x to the power 3 over x to the power 3 minus 4x over x to the power 3 plus 5 over x to the power 3. Okay. And now we could take the limit x go to approach negative infinity. Then I will have 4 plus 6 over x minus 2 over x to the power 3 divided by 2 minus 4 over x squared plus 5 over x to the power 3. Okay. And now if we apply the theorems, okay, oh, it should be this one, right? Okay. As x approach negative infinity. Okay. Then you will see that this term go to 0, this go to 0, this go to 0, this go to 0. Then the only thing that I have left is 4 over 2. Then my answer is 2. Okay. Okay. And again, remember the answer, this answer equal to 2 is mean that to these functions, I have a horizontal asymptotes y equal to 2, right? Okay. But now let us look at the next example. Okay. To this example, again, we have x approach negative infinity. We have 2 to the x, 2 times x divided by square root of x squared plus 1. Okay, just like the example that we have for 5a, then what we want to do, we would like to work with the highest degree in the denominator then. Okay, so in this case, what we want to do is we would like to multiply top and bottom by 1 over square root of x squared. Okay. Then now, what we would like to do here is, I would like to have, again, the limits x approach negative infinity of 2x over square root of x squared, and then all over, okay, now again, remember if we have a square root of x multiplied to 1 over square root of y, this one right here, basically it will be square root of x over square root of y or square root of x over y, right? So same thing here. I will have a square root of x squared plus 1 over x squared. Then now, let's see how we simplify, okay? Maybe let us look at the denominator. So in this case, basically I will have x squared over x squared plus 1 over x squared, okay? And the top that we have is we have 2x here, okay? But now I need to find a way to take care of this square root of x squared, okay? Now, one thing about this is when you have a square root of x squared, okay? Then what is this equal to? Then we know that the square root of x squared equal to absolute value of x, okay? So if this is the case, meaning for absolute value of x, then has x go to negative infinity, or if x is less than 0, then the absolute value of x is equal to negative x. It is equal to x if x is greater than or equal to 0. Okay, so this is how we define the absolute value. Right? And in this case right here, then now let's check it out. Has x approach negative infinity, it means that x is less than 0. Okay, so meaning absolute value of x, or maybe square root of x squared, is equal to negative x then. Okay, so then now we are going to simplify this. Okay, so I will have x and x cancel, so I have negative 2 all over square root of 1 plus 1 over x squared. And then now we know that to this one has the limit go to negative infinity, then this term go to 0. So my answer will be negative 2 over square root of 1. That means my answer is negative 2 then. Okay. Okay. Now let's check the result, okay, using our graphing calculator. Okay. Okay, so now I graph again. I input the y go to the function to my calculator, and then zoom number 6. Do you see that has x go to negative infinity? Then the function that you have is getting closer and closer to this horizontal line y equal to negative 2. Okay. Okay. So wow, this work, right? Okay. So please remember this rule right here. Okay, the square root of x squared is equal to absolute value of x. Okay. Okay. Then now let us look at our next example. How do we actually deal with this problem right here? Okay. So in this case, again, if you think about the problem, it seems that we have x squared has x approach infinity. It actually is infinity, right? So we have infinity, and then take the square root of infinity is still infinity, and then we minus subtract another infinity. So remember, infinity minus infinity is not equal to 0. Okay, keep that in mind. Then how do we actually work out this problem now, okay? What we would like to do or to use is the conjugate pair, you see? Now, again, you will see that a couple times already, right? When you have the expression that I have contain the square root with more than one term, right? Then we work with the conjugate pair, okay? So in this case, I would like to create a conjugate pair. It will be square root of x squared plus 2x plus x over square root of x squared plus 2x plus x. Okay. Again, when we create a term, we could not create just the square root. That means just the top. Okay. We cannot just do this. We have to multiply by 1, right? So that's why we need to multiply top and bottom by the same expressions. So then we multiply 1 then. Okay, then now try to pause the video and then work it out, this problem, okay? Then let's see. So remember, if we have a minus b times a plus b is equal to a squared minus b squared, okay? So then in this case, we will have x squared plus 2x, the square root of this, and then square, and then minus x squared, all over square root of x squared plus 2x plus x. So I have x squared plus 2x minus x squared over square root of x squared plus 2x plus x. Okay. I will have 2x over square root of x squared plus 2x plus x. Okay. Now you will see that this example is really similar to what we did it to be. Okay. Now maybe again try the problem then. Okay, so to this one, okay, my largest power or term is actually square root of x squared. So again, I multiply 1 over square root of x squared, okay, to the numerator and the denominator. Then after I multiply 1 over x squared to numerator and denominator, then I got this. Okay. Then now, back to the definitions. If we have a square root of x squared equal to absolute value of x, then now as x go to infinity, go to infinity, okay, then the square root of x squared, okay, or maybe I should say that here, that means x is greater than 0 now, okay. And now square root of x squared is equal to absolute value of x, which is equal to x now, okay. And now I have the limit x go to infinity of 2x over x all over, this one would be 1 plus 2 over x plus x over x then. So I have 2 over square root of 1 plus 2 over x plus 1. Okay. And then now this go to 0. So in this case, I will have 2 over 1 plus 1. So my answer is 1. Okay. Okay, so then now, again, in this video, we talk about how we use limit to work with horizontal asymptotes. And we also work it out a couple of problems, okay, in these sections, like to see how we evaluate the limit, okay? Okay, thank you.